Bismillahirrahmanirrahim. Rabbi zidni ilma. Nothing in nature blooms all year. Be patient with yourself. Assalamu alaikum everyone. My name is Dr. Sadia Rafiq and under the supervision of Professor Dr. Sara Afzal, today my topic of presentation is light. Learning outline includes the requirement of good lighting, measurements of light, natural lighting, measurements of daylight, artificial lighting, methods of artificial illumination, lighting standards, biological effects of light, recent advantages, and multiple choice questions. Learning outcome. At the end of presentation, participants would be able to describe the requirements of good lighting, measurements of light, natural light, artificial lighting, and lighting standards. Introduction. Environment has been divided into three components. First, physical, which includes the water, soil, air, and light. Second is biological, which includes plants and animals' life. And third is social, which includes customs, cultures, habits, income, and religion. Today, I'm going to discuss the physical, one of the component of the physical part, which is light. Requirements of good lighting. Good lighting is essential for efficient vision. Poor lighting conditions lead to general fatigue and loss of efficiency. For efficient vision, following light factors are essential, which are sufficiency, distribution, absence of glare, absence of sharp shadows, steadiness, color of light, and surroundings. Now I'm going to discuss one by one. Sufficiency. The lighting should be sufficient to enable the eye to discern the details of the object as well as the surroundings without eye strain. And illumination of 15 to 20 foot candles, where 1 foot candle is equal to 10.76 lux, is accepted as a basic minimum for satisfactory vision. Illumination requirements vary from as little as 5 foot candles in stairways and corridors to 100 foot candles in some industries. Distribution. Distribution of light should be uniform, having the same intensity over the whole field of work. Contrast difference in light will strain the eyes and affect adversely the visual acuity. Proper dispersion of light without shadow is necessary for efficient vision. Absence of glare. Glare is excessive contrast. Best example of glare is the automobile headlights at night. The same lights during daylight would not cause glare owing to the absence of excessive contrast. Glare may be direct glare from the light source and reflected glare from the sources such as tabletops and polished furniture. Glare causes annoyance and I cannot tolerate glare because it causes acute discomfort and reduces critical vision. Next is absence of sharp shadows. Slight shadows are inevitable, but sharp shadows are disturbing. Sharp shadows like glare causes confusion to eyes and should not be present in field of vision. Steadiness. The source of light should be constant. It should not flicker because flickering causes eye strain and may lead to accidents. Color of the light. It is not very important so long as the intensity is adequate. Natural light has soothing effect on eye and artificial light should be as far as possible approximate the daylight color. Surroundings. When black object is viewed against a dark background, recognition is difficult. High level of illumination will be required when there is a lighter color contrast. For efficient vision, color scheme in room is very important. Ceiling and roofs should have reflection factor of 80%, wall 50 to 60%, and furniture 30 to 40%. There should not be much reflection from floor, not more than 15 to 20%. Contrasting colors are often used to prevent accidents. Now moving towards the measurement of light. Light is perceived as a narrow wavelength band of electromagnetic radiation from about 380 to 780 nanometers. Light containing all visible waves is perceived as white. There is confusion about unit of light measurements. Light measurement units. There are 4 measures of importance which are given below. Number 1 is luminous intensity, which is a power of light source considered as a point radiating in all directions. It is measured as candela or candle power. Second is luminous flux, which is a flow of light related to a unit of solid angle measured in lumen. Third is illumination or illuminance, which is amount of light reaching a surface measured in lux per unit area. Fourth is the brightness or luminance, which is the amount of light reflected from the surface measured in Lamberts. As you can see in this picture, it is a light source and it is a luminous flux, lumens. It is the luminous intensity, which is made in candela. It is the luminous, which is made in lux, and it is the lumen, which is I perceive, which is candela per square meter. You can see very well with by this picture, simple picture, it is luminous by the light source, and it is the luminous, which is coming through the floor. So light measurement units are description, quantity, measured names, recommended unit, and other units. And for the brightness of point source, which is the luminous intensity, and it is recommended uses candela, or other is candela power. Then the flow of light, it is the luminous flux, and the recommended unit is lumen. Then the amount of light reaching surface, which is illumination or luminous, and recommended unit is lux. And foot candle, lumen per centimeter square. Then the amount of light re-emitted by the surface, which is brightness or luminous, and its recommended unit is Lambert. And this is recommended by the International Organization for Standardization. Now talking about the natural lighting. It is derived partly from the visible sky and partly from reflection. In fact, much light source comes to the rooms by reflection from light-colored objects. Efficient utilization of natural light calls for careful design, location, and orientation of buildings and relationship between buildings. Natural lightings also depend upon the time of day, seasons, weather, and atmospheric pollution. Since natural light is accompanied by radiant heat, all attempts should be made to exclude radiant heat while admitting daylight. General principles in planning best utilization of daylight. Number one is the orientation. The brightness of sky is not constant on east and west, and the direct penetration of sunlight may heat up the rooms unduly in tropics, especially in summers. Buildings are therefore oriented wherever possible for uniform illumination. This is particularly important in respect of schools, factories, and laboratories, where uniform light is required in all rooms. Second is the removal of obstructions. Removal of obstructive items, either wholly or partially, is likely to give the most effective single improvement in lighting. Number three is windows. Windows should be properly planned, as natural lighting within any room is influenced by the amount of visible sky, the size, shape, and arrangement of the window opening. Tall and broad windows, greater penetration and diffusion of light. Rule that window area should not be less than 10% of the floor is now outdated. In modern practice, window area is correlated to the purpose of the room is intended to serve. The usefulness of windows is reduced by covering them unnecessarily with curtains and screens. Interior of the room. In order to obtain the full benefit of the natural illumination, the ceiling should be white, the upper portion of the white light tinted, and the lower portion somewhat darker to give comfortable contrast to the eyes. Measurement of daylight. Daylight factor. Intensity of daylight illumination is liable to change from moment to moment. It is not measured in terms of foot candles. Reliance is placed on a factor called the daylight factor, or DF. It is a ratio of illumination at a given point to illumination at a point exposed simultaneously to the whole hemisphere of the sky, taken as 500-foot candles, excluding direct sunlight. The daylight factor may be summarized as follows: DF is equal to instantaneous illumination indoors divided by simultaneously occurring illumination outdoors multiplied by 100. The daylight factor is determined by modified photoelectric meter known as daylight factor meter. It is recommended that in living rooms, the DF should be at least 8% and in kitchens 10%. Artificial lighting. Daylight cannot meet the requirement of illumination during all hours and during cloudy days. It should be supplemented by artificial illumination for adequate illumination. It should be as close as to daylight. 5 systems of artificial lighting. Number 1 is direct lighting. In this, 99 to 100% of light is projected directly towards the working area. Direct light is efficient, economical, but tends to cause sharp shadows. It should not fall directly into the eyes. Second is semi-direct. 10 to 40% of the light is projected outwards so that it's reflected on the objects by the ceiling. Third is indirect. Light does not strike the surface directly because 90 to 100% of light is projected towards the ceiling and walls. It gives the general illumination of the whole room, but not of any object. Then comes the semi-indirect. 60 to 90% of the light is directed outwards and the rest downwards. Direct, indirect. Here light is distributed equally. No one system can be recommended to the exclusion of others. Methods of artificial illumination. Number 1 are the filament lamps. These are widely used. Electric current heats up tungsten filament and the light is emitted depending upon the temperature. So the important point here is that light which is emitted, it depends upon the temperature of the lamp. Hotter filaments produces bluer lights. Accumulation of dust on bulbs reduces illumination by 30 to 40%, so they should be cleaned frequently. Second are the fluorescent lamps. These are economical in use of electric currents. These are cool and efficient. The light emitted simulates natural lights. The lamp consists of glass tubes filled with mercury vapors and electrodes fitted at each end. The total emission of energy by 2 lamps in the filament, the light is 5% and heat is 95%. In the fluorescent, the light is 21% and heat is 79%. Lighting standards. I respond to range of illumination ranging from 0.1 lux, which is like full moonlight night, to 1 lakh lux, which is bright sunshine. There is considerable confusion about standards because of the adaptability of the eye. Many standards have been published, but these are arbitrary. The visual efficiency increases with the increase of illumination, but the curve flattens out at the higher level. The following values in lux have been suggested by Illuminating Engineering Society. As you can see, it is the visual task. Casual reading needs 100 lux of illumination. General office works 400, fine assembly 900, very severe tasks 1300 to 2000, and watchmaking needs 2000 to 300 lux, 3000 lux. Now moving towards the biological effects of light. Daylight is being used as therapeutic measure in premature infants with hyperbilirubinemia. Other biological effects of light includes effect on the biologic rhythms of body temperature, physical activity, stimulation of melanin synthesis, activation of precursors of vitamin D, adrenocortical secretions, and food consumption. Now moving towards the recent updates. It was one of the article which was on the optimizing window to wall ratio for conserving energy in office buildings for cooling dominant climates with and without daylight utilization. In this, the construction of fully glazed commercial building facades responsible for high energy consumption has become a common architecture practice worldwide, irrespective of the climate. This paper presents the methodology to optimize the window to wall ratio, WWR, with and without daylight utilization to reduce energy consumption in office building for the climate of Lahore, Pakistan, using a simulation tool, which is COMFEN. The impact of solar heat and daylight entering through the building facade and in reference to different WWR, the orientation was explored for the selection of optimum WWR. The optimum was selected on the basis of least energy consumption while achieving a threshold lighting level. When daylight is not utilized, the energy demand is minimized by lower possible WWR. With the daylight utilization, energy demand is optimized by 13 to 30% according to orientation. And with the WW with daylight utilization offered a more balanced solution. The methodology used in this can be applied to any location around to the world to find optimum WWR for any glazing type. And in the second article, it was the evaluation of daylight intensity for sustainability in residential building and cantonment cottages, Multan. In this, it was mentioned that daylight is useful and effective source of energy saving and visual comforts in building. Occupants accept good daylight in their living space for better living condition. The quality and quantity of the natural light entering into a building depends on both internal and external factors. And the daylight strategy basically depend upon the accessibility of natural light that is determined by the latitude of the building site and the conditions surrounding the buildings. And after in this article, and they have given some recommendations, which are entrance of sufficient daylight into building can reduce the cost of energy. Thus, proper design in this regard makes the building energy efficient. And second recommendation was entrance of daylight certainly depends upon the orientation of different components of the building. The next is the study will help architects or building design to locate on or orient major buildings units like bedrooms and living halls in a position where there would be more penetration of daylight, which results in minimizing the electricity consumption. Fourth, as we know, insufficient daylight into building can seriously affect the health and working efficiency of the working personnel. Existence of moisture and insufficient daylight is a favorable place for breeding of anaerobic bacteria, which creates odor. There is a government of Pakistan Ministry of Housing and Works has this brochure, Building Energy Code of Pakistan. In this code, they have given this code gives minimum performance standards for building windows and openings, heating, ventilating, and air conditioning, however, equipment and lighting. They also, one of the element in this is the lighting. And the scope in this is the section describes recommendations and requirements for interior and exterior electric lighting and recommendations for day lighting within buildings. It is a booklet which has all the information in it. Now moving towards the multiple choice questions. Interior designer was designing a house in ABC city, and he was much concerned about the proper illumination of the room according to specific recommendations. For living room, the recommending DF daylight factor should be at least 8%, 10%, 12%, and 14%.
A.
Yes, the correct answer is A. Civil engineer, while designing a room in a building, was very much concerned about lighting standards, which have been published, but there is considerable confusion about standard because of the adaptability of the eye. For casual reading, the recommended illumination standard is 2000 lux, 1000 lux, 100 lux, 200 lux.
C.
Yes, C is the correct answer. For reading purpose, it is 100 lux. There are 4 light measuring units of importance. One of them is a power of light source considered as a point radiating in all directions. It is measured as candela or candle power, and it is a unit of luminous flux, luminous intensity, illuminous or brightness.
B. Luminous intensity.
Yes, the correct answer is luminous intensity. It is the intensity of the light coming from the source. In an office XYZ, the concerned person was allocated with the task of proper lighting in the office rooms. Illuminous is a term that describes the measurement of light falling onto, illuminating, and spreading on a given surface. Which of the following will need the highest level of illumination? Bedrooms, hospital wards, railway platforms, or proofreading?
Railway platform.
D.
D, the correct answer is the proofreading because it is the work to do. You have to check the grammatic mistakes or everything. You have to study the document in very much detail. So the highest level of illumination is required in proofreading. Most of the accidents on the highway during night times are due to glare of the automobile headlights. Glare causes annoyances, and I cannot tolerate glare because it causes acute discomfort and reduced critical vision. It is caused by color of light, excessive luminance, surroundings, or steadiness.
B.
B is the correct answer. Excessive luminance is the glare. So B is correct. An architect XRZ knows very well that good lighting is essential for efficient VM. Poor lighting conditions lead to general fatigue and loss of efficiency. For efficient VM, falling light factors are essential except sufficiency, steadiness, presence of glare, or absence of sharp shadows.
C.
Yes, C is the correct answer. There should be the absence of glare rather than presence. A researcher, XYZ, was working on a project to see the association of light and different health hazards. He found out that the light has no association with the following health hazard. Number 1, eye strain and irritation, headache and fatigue, skin problems, and nystagmus.
C.
C.
The correct answer is D, nystagmus, because it is the problem in which there's a lack of communication between eye and brain, and it has no concern with the light. So D is the correct answer. An architect XRZ is building a house with proper lighting. Windows should be properly planned as natural lighting within any room is influenced by the amount of visible sky, the size, shape, and arrangements of window opening. Windows with greater penetration and diffusion of light are small and cubic, rectangular and sleek, tall and broad, square and multiple. The correct answer is C. Tall and broad windows have greater penetration and diffusion of light. A designer ABC is very much concerned about the interior of room regarding lighting. In order to obtain the full benefit of natural illumination in the room and to give comfortable contrast to the eye, ceiling should have mosaic, ceiling should be dark color, ceiling should be white, and ceiling should have abstract design.
C.
Yes, C is the correct answer. Ceiling should be white. Last one, daylight cannot meet the requirement of illumination during all hours and during cloudy days. It should be supplemented by artificial illumination for adequate illumination. The radiant efficiency of the luminous source depends upon shape of the source, place of the source, wavelength of the light rays, or the temperature of the source. The correct answer is D, temperature of the source. As I have told you, in the artificial lighting, temperature of the source is very important for the light. So D is the correct answer. It is my B, and thank you references, and thank you so much.
Okay. Thank you very much, Dr. Sadia. Another good presentation. There are few points that I have observed during the presentation.